in degrees, we had two special triangles to help us evaluate trigonometric ratios exactly. We have those same triangles in radians. So in degrees, we had a triangle that was 45 degrees and 90, and the ratios of our side lengths for 1, 1, and root 2. Now that we're in radians, the triangle is the same, except our angle measurements are pi over 4 and pi over 4. Similarly, we had a 30, 60, 90 triangle. Now in radians, we have a pi over 3, pi over 6, and then pi over 2 triangle. And the ratios of our side lengths are 1, root 3, and 2. And then these values should actually be 30 degrees is the same as pi over 6, and then 60 degrees is the same as pi over 3. So we're just going to draw out some diagrams for those angles so that we can visualize where they are. We have our triangle right here, and our angle in standard position, so pi over 4 is right here in our first quadrant. In my right-angled triangle, I know that this side is 1, this side is 1, and this side is root 2. We can also denote these side lengths as x and y and r for our x component, our y component, and then the radius. Since sine is our opposite over hypotenuse, we can also denote this as y over r. So that means that the sine of pi over 4 is 1 over root 2. Our cosecant of pi over 4, our reciprocal trig ratio, is the reciprocal of that. Cosine is our adjacent over hypotenuse, which is x over r. In this case, it is also 1 over root 2. Secant is our reciprocal trig function, which is root 2 over 1. Tan theta is our opposite over adjacent, which is y over x, which in this case is 1 over 1, which is just 1. And then our cotan is the reciprocal of that relationship, which is also 1 over 1. We're going to repeat the same thing for pi over 6. Use a different color. So pi over 6 is about 30 degrees, which is here. Pi over 6, in my triangle, I also have a y component, which is 1. I have root 3, which is my x component, and then my hypotenuse, which is 2, which is my r value. So I know that sine is y over r from above. So my sine of pi over 6 is 1 over 2. My cosecant or reciprocal trig function is 2 over 1. Cosine is x over r, or my adjacent over the hypotenuse, which is root 3 over 2. My secant of that is just the reciprocal, which is 2 over root 3. Tan is the last one, which is y over x, which is 1 over root 3. And then my reciprocal, or cotan, is root 3 over 1. The last one that we're going to take a look at is up here, which is pi over 3. And I'll use black for this one. I don't think I've used black yet. So I'm going to draw pi over 3. This is 60 degrees. Whoop. 60 degrees. This is pi over 3. So when I set up my triangle, I'm going to have my opposite side now is root 3. This is my y component. My adjacent side is 1. This is my x component. And then my hypotenuse is 2, which is my r component. Sine is the opposite over hypotenuse, or y over r, which is root 3 over 2. The reciprocal of that, or cosecant, would be 2 over root 3. Cosine of pi over 3 is the adjacent over hypotenuse, or x over r, which is 1 over 2. The reciprocal of that is 2 over 1. The last one is tan, which is y over x, which is root 3 over 1, and then 1 over root 3. So very similar to the values for pi over 3, but opposite because you're looking at a separate reference angle in the triangle. So if you're finding the values on the axis, you can use the same idea of y over x. So let's sine of pi over 2 is going to be my opposite side, which is the y side, over r. My cosine of pi over 2 is going to be x over r. And then my tan of pi over 2 is y over x, so tan of 90 degrees. Okay, so we're looking at 90 degrees. I'm going to draw my angle here. So this is where my terminal arm would be, and I'm measuring all the way up here. In this case, my x component is 0. So that means my cosine, I would have 0 over the radius. So that means the cosine of pi over 2 would be 0. I also, in the sine of pi over 2, the y would be equivalent to my radius. So I would have r over r, which would simplify to 1. And then in terms of tan of pi over 2, I would have y over 0, which is undefined. So my angles are similar at the other sides. If I do them over here, so at pi, which is 180 degrees, now this time my x component is equal to the radius, and my y component is equal to 0. So sine and cos flip, and then my tan now is going to be equal to 0. So we can write that up over here. X is equal to r, y would be equal to 0. So I can do the sine of pi would be y over r, which is 0 over r in this case, which is then going to be equal to 0. Cosine of pi is going to be x over r. X is at a maximum here, which is equal to the radius, which is equal to 1. And then the tan of pi would be equal to y over x. Now in this time the y is equal to 0, so that means the tan of pi is equal to 0. So you can repeat this similarly for the other two values. And we would actually have, I'm going to add here, this is minus r in this case. So x is equal to minus r in that direction. So we actually have a value of -1 for pi. And then I'll fill in the values for the other two axes here. So you've got x is equal to minus r. So I've got x is equal to minus r, which means that cosine of pi is -1. Tan of pi would be equal to y over x. In this case, y is 0, and x is equal to minus r, so tan of pi will be equal to 0. Similarly, as we go down here, now my y component is equal to minus r. My x component is equal to 0. And then as I go all the way around to the last one, this would be 2 pi. I would have my y component is equal to 0, and here my x would be equal to the positive radius. You can also remember these values by remembering to sketch the graphs. So sine graph starts at 0 and is broken into 4 equal sections, goes in between +1 and -1, and goes from 0 to a maximum at pi over 2, back to 0 at pi, to a minimum at 3 pi over 2, and back to 0 at 2 pi. Your cosine graph goes down like this, looks like a cup. Also goes in between +1 and -1, starts at a maximum at 0, passes through the x-axis at pi over 2, gets down to -1 at pi, and then 3 pi over 2, and finally goes back to a maximum at 2 pi. So those are values that you need to remember in order to be able to evaluate the trig ratios.